Today we are going to discuss about colorimetric estimation of copper. So we have seen how to estimate FAS using potentiometry, how to determine or the endpoints of different acid mixtures by determining the conductance, and how to determine viscosity. So today we are going to determine how to find out the amount of a substance present in the given sample by measuring the absorbance. Already you have seen how to find out the amount of substance present in compound by measuring its potential, measuring conductance of the reaction. Right. Today we will see how to determine amount of substance present by measuring its color. Okay. Colorimetric estimation depends upon Beer-Lambert's law. What is Beer-Lambert's law? We'll discuss. So colorimetric estimation can be done only for substances which are colored or which gives color when we add certain substance. So chemical analysis. So the Beer-Lambert's law, colorimetric estimation depends upon Beer-Lambert's law. Beer and Lambert's were two different scientists who were working on the same thing on a same time. According to Beer's law, the intensity of the transmitted light decreases as the concentration of the absorbing substances increases. Lambert's law states that the intensity of the transmitted light decreases as the thickness of the absorbing medium increases. So when we combine both are right. So we are going to combine both. The Beer-Lambert's law states that the intensity of the transmitted light decreases as the concentration and thickness of the medium increases. So here, what are we going to do? This is Beer-Lambert's law. A is directly proportional to C and T. C is the concentration of species, T is the path length. So in order to remove the proportionality constant, there is epsilon. So what are we going to do? Path length. Path length is the amount light travel distance. Path length is this is the light incident and this is the sample cap. The distance between the light given and the sample. Okay, that is called as path length. If you keep the path length constant, then absorbance is directly proportional to the concentration of the species. Okay, so keeping that in mind, colorimetric was designed. So how do you go with this experiment? We're going to prepare blank solution. So what do you mean by blank? So blank contains everything except the sample. What is sample here? Copper sulfate. Okay, we're taking 5 ml ammonia and making it up to 50 ml of by adding distilled water. So next we're going to add 5 ml. We have 3 different burettes. One bit we're going to fill copper sulfate, other bit we're going to fill ammonia, other bit we're going to fill water. So first we're going to take 5 different flasks, name it as 5, 10, 15, 20, 25. The flask named 5 we're going to add 5 ml of copper sulfate. For flask named 10 we're going to add 10 ml of copper sulfate and so on. For each and every flask, we're going to add 5 ml of ammonia, including the blank. So we're going to give some test solution. What is test solution? The flask named 5 contains 5 ml of copper sulfate. Flask named 15 contains 15 ml of copper sulfate. The flask named test solution contains some volume of copper sulfate we are supposed to find out. That is the aim of the experiment. Okay. When we add ammonia, copper sulfate reacts with ammonia, giving a blue colored complex that is cuproammonium sulfate. The intensity of the color increases with increase in the concentration of copper sulfate. So after adding these, we are going to dilute the mixture copper sulfate and ammonia with water and mix it well. We have a set absorbance knob in colorimeter. I'm going to set it to 0. So I'm going to set the filter to 620 nanometer using colorimeter. So we're going to so then you're going to keep a blank solution, and for blank, since there is no copper sulfate, the absorbance should be 0. Later we're going to take 5 ml, 10 ml, 15 ml, 20 ml, 25 ml. We're going to measure absorbance for each and every sample, including the test solution. Later we're going to plot a graph of absorbance versus volume of copper sulfate. So here the graph should pass from origin. When you plot, the graph starts from origin. Why? Because the absorbance for the blank is 0. Okay. So 5 ml it is this, for 10 ml it is this, for 15 ml this is absorbance, for 20 ml this is absorbance, 25 ml it is absorbance. So for all colorimetric estimations, the graph should start from the origin. Okay. Now for test solution, you have the absorbance, but you don't know the volume of sample, right? So go here, y-axis, check for the absorbance of test solution, draw a parallel until it touches the curve, then drop a perpendicular. This gives the volume of test solution, volume of copper sulfate present in the test solution. So there is a small demo how to do the colorimetric estimation. You can go through here. Okay.
We are starting with the colorimetric estimation of copper. This experiment is applicable for colored solutions, and starting with the demo for this experiment. First we have to take the 3 burettes. First burette you have to fill with copper sulfate, and the second burette you have to fill with the ammonia solution, and the third burette you have to fill with the water. First copper sulfate, second ammonia solution, and third with the distilled water. And next step is you have to take 7 volumetric flasks will be there. It will be marked as 5, 10, 15, 20 and 25, and then 2 more flasks will be extra. One is blank and the other one is a test solution. Even it contains the same copper sulfate of unknown volume. So totally you will have 7 flasks. First step is you have to draw, for the first flask you have to draw 5 ml of copper sulfate, and for the second you have to draw 10 ml of copper sulfate, and for the third one 15 ml, 20 ml and 25 ml. Once again I repeat, you have to take 5 different volumetric flasks which are marked as 5, 10, 15, 20 and 25. The same amount of copper sulfate has to be drawn, 5, 10, 15, 20 and 25 ml, and then 2 more flasks will be there. One is black and the other one is the same copper sulfate where it is of unknown volume. Step is, first step we have drawn copper sulfate into 5 different volumetric flasks, 5, 10, 15, 20 and 25 ml. Second step is for these 5, 10, 15, 20, 25, and also for blank and test we have to add 5 ml of ammonia to all the flasks. Second step is add 5 ml of ammonia to each and every flask, and finally you have to make up the solution with the distilled water, and you have to mix well and keep the solutions ready. When you prepare the solutions, it will be looking like this. Lower the concentration of the copper, it will be light in color, and higher concentration copper solution, it will be darker in color. So you have to keep the solutions in order once again. 5, 10, 15, 20 and 25 concentrated solutions of copper sulfate, and blank solution, it is colorless in color because it does not contain any copper sulfate, and this is a test solution which contains unknown quantity of the copper sulfate. This is about the preparation. Once again I will tell, we have to take first 5, 10, 15, 20 and 25 ml of copper sulfate, and second step add 5 ml of ammonia to all the flasks. Third step is make up the solution accurately up to the mark with the distilled water. And 1, 3, mark it on, tie into the main line passing through the origin, then extend it to the x-axis. Wherever it meets, this is the volume of first take the black solution, pipe it well, keep it in the knob provided and set the OD for 0. Set the OD for 0. This is the only setup we have to do. We have to take the blank solution in the cuvette, keep it in the knob provided and set the OD for 0. Okay, after setting the OD for 0, you just have to measure the readings for all other solutions. No other setups are there. Set the OD for 0 for blank, then throw out the solution, then take the solutions one by one starting from 5 to 25 and measure the optical densities. Next I will be taking solution number 1, is 5. Okay, take the solution 5, wipe it cleanly and keep it in the knob provided and just measure the readings. Whatever it shows, you just have to write them. Okay, so for 0.5 it's showing the 0.06, right? So in the same way, how to measure the optical density for all the solutions. So it will be getting like this. When we measure the optical density for all these solutions, we will be getting the values like this. After once the values are recorded, we have to plot a graph. We have to plot a graph of, on x-axis we have to take volume of copper sulfate, and on y-axis optical density values we have to take. So when we take like this, we will be getting a graph like this. This is calibration curve, which is a plot of body against volume of copper sulfate, and you must get a straight line passing through the origin. Now we have taken 5, 10, 15, 20 and 25. For that we have taken the optical densities. Now one more value is extra. Okay, for test solution we have optical density value. We don't know the volume. Okay, where is the optical density here? In the y-axis. So 0.13, mark it on y-axis. At 0.13 you have to mark. Draw a line to the main line passing through the origin. Then extend it to the x-axis. Wherever it meets, this is the volume of unknown solution. Volume of unknown solution dash ml. Okay, volume of unknown solution, which is noted here as V. Okay, so we know the value of V now. We have to take the readings from the instrument for all the solutions 5, 10, 15, 20, 25, and at last for a test, then plot a graph of optical density against volume of copper sulfate. We will come to know the volume of the test solution given. After once you know the volume of the test solution given, you have to do some small calculations. The calculations include, see here 1 ml of copper sulfate is equal to 63.55 by 249.6 milligrams of copper. So 4 milligrams of copper sulfate is equal to, because we are working the solution of concentration 4 milligrams. So 4 milligrams of copper sulfate is equal to 63.55 by 249.6 into 4. Okay, so we will get a value here. Okay, that is x. You will get one value, that is x. Okay, if you multiply with the volume of the test solution, you will be getting the final value, that is dash milligrams of copper sulfate. Dash milligrams of copper sulfate per liter you will be getting. Take a graph like this.
Thank you guys.